Okay, in this video we're going to continue where we left off, solving some practice problems in data science. We've done everything in generic plain Python so far, and now we're going to use some more professional style data science tools. So make sure you have Jupyter Notebook installed. The easiest way to do that is by installing Anaconda. You can look in my videos for installation tutorial on Anaconda. But just to recap what we've done so far, we've been covering these data science problems all in plain Python. We've got some data sets, we've got some equations, those basic business problems, revenue, gross profit, net profit. And so we have sort of three sets of problems. So we start out with the customer data and we look at statistics on the data. So in data science, a lot of times your data is unclean, right? And so you need to clean it. So there's missing data. Sometimes in this particular case, we had the fields zip and state were swapped in several instances, and so we had to flip those around. All right, so we're going to do this problem set first, and then we're going to clean our data. And then we're going to do the second problem set, and then finally the second problem set is monthly data. So we're talking about which months had the best total revenue, gross profit, net profit, and also the worst of all of those. So we're going to kind of pair these problems together. So 6 and 9 is the largest total revenue, and then the smallest total revenue. So we'll do that together, and we'll make one big chart so we can see everything together. And that's kind of the nice thing about Pandas too. You'll see as we construct these data frames, you get to see more information in a nice table, and it's easier to comprehend. All right, so first let's get started here. I'm on my desktop. I have installed Anaconda such that I have to activate it. So I type conda activate. If you're on Windows, you can just go to the Anaconda terminal and it should be activated automatically. But then this sets up my Python environment so that everything for Jupyter Notebooks is installed, including pandas, matplotlib, and all sorts of good stuff. So what we want to do here is call Jupyter Notebook, and it's going to run a server. Right, and so I'm just running this on my desktop, so wherever you run it, that's where it opens up, and you can see all these other files that I've been working on in my desktop. We want to create a new file, Python 3. All right, and you get something like this, and notice unsaved changes. The first thing we want to do is change the title to sales analysis. Okay, and that will actually change the file name for us as well. And so if you're unfamiliar with Jupyter Notebooks, go ahead and look around a little bit, see what you can do. You have the concept of a cell. That's the core idea behind this. Every time you want to add information, you have a cell, and there's a couple of different types of cells. You have a markdown cell, which is a shorthand version of HTML or markup. And so we can make headings and dividing lines and little things like that with Markdown, and we'll do that a lot to make, because this is data science, we're going to probably be presenting to somebody at some point, some a business, the board of a business or something like that. So we need to present the data well, so we're going to use Markdown for some of that, and then when we want a code cell, we're going to use just press Y. And so the way you do this is, here you see it's green. I'm actively typing in the cell. If I press escape, it's blue, but the cell is still highlighted. Okay, so if you want to change the cell type, you have to be in the blue mode where the cell is selected, but you're not actively editing it. And so I can change this to a markdown cell. I pressed M, which is the keyboard shortcut, and we see that goes away. Right? If I press Y, we're back to Python. If I press enter, I enter the cell and I can start typing stuff. Some other basics. If you want to run a cell and then select below, shift enter, if there's no other cells, it will automatically create a new cell at the end. Right? So we'll have various cells, and it's tricky in Jupyter Notebooks because you can run cells out of order, so be careful of that. All right, so let's get started. If you need more basics, this is probably not the tutorial for that, but that's the general idea. So what we want to do is kind of set up something that looks like this. I'm gonna move that over here as my little cheat sheet. All right, so we've been taking all of these data files. It's a good idea when you're working on this to have a little bit of setup, so it's easy. You can easily reference these things from within your workspace. So when we were doing the Python files, I added all these comments at the beginning, and so we're going to do something similar here. So we're going to start out with the equations first. All right, so let's pop back over here. Okay, so first thing, escape. We press escape and we go to the blue mode, and I want to make this a markdown cell, so I press M, I press enter. Now we can type in markdown, so the hash is like the H1 tag, and we type sales analysis. And then to run the cell, shift enter is what you're going to be using most. And if there's no cell underneath, it'll automatically create a new one. Otherwise, it will just run it. Okay, and if I want to edit it again, I can click on it, double click, and now we see the markdown. Okay, sales analysis, again here, escape, markdown, enter, and this is equations, right? So, I'm going to use that, and in markdown you can use backticks to indicate code. I like to do that for mathematical expressions as well. So these are sort of our mathematical expressions, our equations. And if you want to make a horizontal rule, an HR tag in HTML, you can add 3 hyphens on top, right? Now we can hit shift enter. And so we get this horizontal rule. We've got an H2 tag. You do that with 2 pound symbols instead of 1, so it's slightly smaller. So this is an H1, H2. And then we've got our equations here. We want to clean that up a little bit, so we'll do 1 per line like that. Or better yet, oh, that'll work. All right, so next thing, we have our data files we need to add. Okay, so escape, M for markdown, press enter, data files. All right, so what are our data files? Double click on that again. We need another one of those horizontal rules. Okay, so if we look back at our other file here, these were the files we were using. Right, so we can kind of copy and paste this. So these are where all the files are located. They're all on the cs.indstate.edu website. Okay, and so this is going to be the URL prefix that we're going to use, and then all of the file names: customers, expenses, products, tax, sales, etc. Okay, so those are the data files. In Markdown, we have to separate these by space so it prints out nicely. All right, and you could click on one of these and it would take you right to the particular data file, but we're going to be using the Pandas module and we're going to need these URLs, so this is just for reference. Again, we're setting up our problem. So here we have another cell, and we want to press escape, press M to make it a markdown cell, and then yet again we have the horizontal rule, and then we're going to say problem set 1. And then this is customer data stats. And basically we're going to go through and take each one of these. Just setting up the problems here. And remove the Python comments because in Markdown those are H tags. But this is how you make a list in Markdown. You can say 1 point, and it will automatically make that into a list, a numbered list. So it gives us 1, 2, 3, 4, 5, right? So using the ordered list tag and list item tag in HTML. All right, so that's the problem set 1. And then we have problem set 2. So Markdown cell, problem set 2. All probably be in the same cell. And grab all of those problems. And let's see, problem set 2 is about sales data, but it's monthly sales data. And then problem set 3, this is about sales data, but it's annual, and it's more the products. So this is monthly performance, and this is annual product performance. And what do we have here? These problems here. All right, and again, we get rid of the Python comment because it's an H tag in Markdown. So here are the problems. So we've got a nice setup. We've got everything we need to reference here. I'm going to zoom out a little bit so we have a little bit more screen real estate to work with. Okay, so that's pretty good. Now what's next? We need to kind of set up our code. What are we going to be doing in Pandas here? So let's add one more Markdown. So escape im makes it a Markdown. Press enter. And we're going to say hyphen, hyphen, hyphen for our horizontal rule, and then code setup and helpers. Okay, and then shift enter. So every time you want to execute the cell, shift enter. Right, that's what we're going to be using most of the time. All right, so now we're going to actually get to some Python code, and what we want to do is import pandas. Now this should work if you've installed Anaconda. Pandas should be installed by default. Again, watch the tutorial videos if you haven't installed Anaconda, and then come back to this. So usually people say import pandas as PD, and so PD is what we're going to be using because we use the pandas library a lot. And we want to specify our URL prefix. We're going to need that. So the URL prefix is basically the beginning part of all of our URLs, so we don't have to keep typing that over and over. So I'm going to store that in a variable. Right. And then what else do we need? We need that states dictionary. So we're gonna do things a couple of different ways here. We're gonna use pandas in kind of a naive way because we came from plain Python, and we'll do some things that you might think might be the best way to accomplish things in pandas, and it's kind of similar to the plain Python. But then after we do it the naive way, we'll do it more in kind of like a pandas way. All right, so we're going to need some of these things that we had previously. So one of the things we had was this states dictionary. Right, so this goes from the 2-letter abbreviation for the state to the long state name. Okay, and then we also added the empty string maps to the empty string, so that was kind of useful for us at times. All right, so that's sort of the plain Python way of doing things, but in terms of pandas uses data frames. So a data frame is kind of like what we were doing with our read CSV file. It is a collection of, it's a table basically, and it's there's labeled fields. So it's kind of like an array of dictionaries, but it's not an array. You have an index, but the index is not quite like an array. The index is more like a dictionary because the index starts out numbered, but you can name it too. So it's a little bit of a blend between an array and a dictionary. So, and it's kind of nice. It's got a lot of features. So we're going to make a data frame, and what is the data that we want to be in our data frame? We're going to say states.items, and this is going to be a list of tuples, and each tuple is going to be, the first value is going to be the 2-letter code, and the second value is going to be the long state name. So this is the data that's going to get created, and if I just run this by itself, I can type .head, and it gives me the first results, right? So this is going to give me the beginning results, and instead of listing out the entire thing, or if I said states.df by itself, right, shift enter, it gives me all the states. It's kind of a lot. I just want the first several, .head, and if I can specify, you know, the first 8. All right, so those are my states, and you see we have index values on the left. So this is the index for this particular row, and then this is the index for the column. All right, but what you can do is you can name these, and it's much better to do that. So we want to name the columns, and we'll name them abbreviation, and then state. All right, and then if we run this, we see we get a nice little table, right? And so what's stored in this df, this stands for data frame, so you'll see df a lot. This is pandas.dataframe. And there are these little tables, and you can change the index on the column as well. We could make the index value a 2-letter code if we wanted to, and let's go ahead and do that. So we're going to, instead of using these default index values, we're going to set the abbreviation to the index value. So this is kind of like when we did a read CSV and we added a primary key. So this is basically making it so we can easily access one of these rows instead of knowing what the index is or searching through all of them for AR, by the way, or for example, or AZ for Arizona. We can just reference that directly because that is the index. Okay, so how do we do that? We can say states data frame, and we can say the .set index, and we're going to set that to abbreviation. So we're specifying the column that we want to actually be the index instead of the index that's automatically generated. Now, interesting about the index, as you can filter these data frames, remove items, drop rows and columns, and so it's not like an array where these won't always be numbered like this. For example, if I were to get rid of this row, it would still go 0, 1, 2, 3, and then go to 5. 4 would just be gone. So that's sort of a distinction between this and a list, is because a list, the indices, if you remove an item, then all of the indices change. But for data science, we don't want those to change because we want them to be references to particular rows. And so they start out being numbered, but we can change them like we are about to here. So we're setting the index to abbreviation. And this is important. So we set the index to abbreviation. This actually returned a new data frame that had the index set to abbreviation. And then this was the old data frame, and we just printed out the old one. So if I actually want to modify the data frame I'm talking about, I have to say in place equals true. And you see this a lot with pandas. Okay, so this is going to modify the index of the data frame. So in place true means I'm actually modifying this one. And so now when I reference this one again, we see this is now the index. We got rid of those numbers on the side, and then it has one column state. All right, so this is sort of the pandas way of doing things, and this is kind of how we did things in the plain Python world. So we're going to be using a lot of different data frames and tabular data and doing things that way. All right, what's another helper? We had the months array. So we're talking about annual data, so this is going to be very useful. But in terms of pandas, we don't necessarily use arrays as much. I mean, we do some, but the idea of an array is more or less a series. Okay, so a series is sort of like one column of a data frame. So this data frame really only has one column. A series is basically a column of a data frame. It's like an array. And so if I want to say months as a series, I'll say PD, which is pandas dot series, and I'm going to create one of these series. And what's the data I want to use to create the series? I'll say it's my months data up here, and then I can say months series dot head. and then Shift Enter. And we see the idea of a series. It's similar. It's got the index and then one column of information. So series you can think of as an array. It's slightly different, but it's like one column of a data frame. And a data frame is a bunch of series. All right, so these are our helpers. It also says dtype. This is the data type. So pandas is based on the NumPy module. And so all of the types are NumPy types. So object generally means string, but it could also be anything else. You can have, if it's a dtype object, that could be a dictionary or a list or pretty much anything. So, but strings are object types because they're essentially arrays of character data. All right, so let's get into the problems. So we're going to say escape m, enter, problem set 1. And then escape, enter, markdown, problem 1. So let's go up and copy problem 1. Let's see what we have here. So we'll set this as an H2. So given the customer CSV data file, what percent of the first name fields are left blank? So that's what we're trying to solve. And so let's go to Python, and first let's get our customers data. So customers, and we can use pandas.readCSV, that function. So it's got a read CSV function like we created, except theirs is much better. And so what we're doing is we need our URL prefix, and then what file do we want? We want our customers.csv file. Okay, so this is going to give us a data frame. So by default, Pandas just reads in the CSV. There's lots of different options depending on what your CSV file is. We're using the defaults because our files are formatted such that they work with the defaults. But this gives us a data frame in customers. And so then we can just say customers.head and take a look at the first, oops, screen. Sorry, my screen messed up a little bit there. So we can take a look at, where'd we go? Here we go. We can look at the beginning of that file. So customers.csv. And so this gives us the first 5 entries. If we want to know, how many entries are in here, there's a property called shape. We can say customers.shape. This gives us the shape of the data frame. So there are 7 columns, 1, 2, 3, 4, 5, 6, 7, and then there are 1,256 rows, right? So each row is a record of information. All right, so this gives us our customers data frame, and we can look at the head, like I said. We can also look at customers.tail. So sometimes you just want to look at the end, and you could specify a number here. Let's look at the last 8 items. Shift Enter. This gives us the last 8 items. If you don't specify anything, it's 5. Or we can do something that's kind of nice, customers.sample. And this gives us a sample of 5 random entries, right? And so we can see that they're random entries because we can look at the index values to see that they're just sort of random entries. Every time you run it, it should be different, right? It just grabs some entries so you can kind of look at this data. Run this a few times. See if we can find any of those swapped index values. Okay, so we can't find any randomly, which is fine. There's not a whole lot of them. So what we want to do is probably locate them programmatically, and we'll do that next. But for now, let's take a look at, we always want to explore our data. So let's say customers, and we want to see is in A. So is in A stands for is not applicable. So it's the same as saying is null. So in pandas, there's a concept of null, and that's not a number for number types. and by default, if you have like an empty string, it sets it as NaN. So these NaN values, not a number value, is NA. It basically means it's null. It means there's no value. And so what we want to do is look at our data, and we want to find the sum of all of the is NA fields. Okay, so customers is our data frame. We're checking is NA, so it's going to check all of the records for any NA fields and sum them up. Okay, so here customer ID, there's no missing customer IDs. That's good. Here we have 66 missing first names, last names, 40 missing. We have 27 missing states and 16 missing zips. Okay, so that's going to give us kind of our numerator, and it's all going to be over, if we look at the shape, that's going to be over 1256. We can also get the length by doing length of, that gives us 1256 as well. All right, we can also look at the data types. So we can say customers.dtypes. Shift enter. So customer ID, by default, Pandas tries to coerce the data however it thinks it's supposed to coerce the data. So if it can be converted to an integer, it tries to convert it to an integer. So all these customer IDs are integers, and so it does that. Here we have first name is object. That makes sense. They're strings. Last name is string. These are all going to be strings. Why is zip code an object? That's because it has missing data. And so whenever you have missing data, these would all be integers, except we have missing values. And so it's not all type integer, right? There are null values in there as well, or NaN values. So the entire column can't be called integer because it's not. All right, so it defaults to object if there's going to be any null values, and we already know there are. So let's go through and try to solve some of these problems. What we can do is, one thing we might want to do is convert a type. So these customer IDs, they're not really meant to be numbers per se. We're not supposed to be doing any mathematical calculations on them. So we can change these values. We can say customers customer ID. So this is going to select one column from our data frame, and this gives us a series, right? So our customer, and then the index number, and then this is the one column customer ID. If we look up here, this is the index number and then the customer ID. So when we access a data frame and then access with the column name here using the square bracket selectors, this is going to give us a series that's just that column, right? And so what we're doing here is we want to say customers, customer ID, we want to set that equal to customers customer ID. Now dot as type. So this allows you to specify the type, and it casts the way Pandas works is when you have a series and you have a method on the series, this applies to all of the elements in the series. Okay, so as type, we're casting the entire series as a string. So here we saw customers, customer ID, and we see the D type is int64. So now we're changing in our customers data frame, we're changing this column, which is a series. So all the columns are just series. We're changing it to the same series, but then we're applying string to all of those, right? So we can run this, and we can look at customers, customer ID here. We'll just do it like this, and it should give us, it's changed, the type has now changed to object because we converted all of these to strings. Okay, and so this did modify our data frame. Okay, so when you access something like this and you set it equal, you're using the assignment operator, it will modify the data frame. And it modifies that column. All right, what else can we do? Here, our customers, we don't really need this index because we have a special index of our own, right? We have the customer ID field, so we can set this to the index instead, right? So let's do that. We'll say customers.setIndex. And this is just kind of the general information. But once you know Pandas a little bit better, you'll fly through this, and it'll actually be a lot easier to do some of this stuff. But I'm trying to go over some of the basics. So in place equals true, and so this is going to modify this data frame in place. All right, so we're actually modifying this current data frame, and then we say customers head. And these are our customer IDs, and they are now the index. Okay, so that means we can access items by index. Now, if you want to access items by index, you can do something called, you can use the loc accessor, location, and this is kind of like the normal square brackets, but the normal square brackets is selecting on either a column or a row, and it's a little confusing. If you want to do both, or if you want to be very specific about what you're accessing, what location are we accessing? I want to access rows, comma, columns. So what rows do I want to access? I want to access 1000 and then all of the columns. Okay, so this should get this first value. So the colon is kind of like selecting all of the values there. And this gives us a series since there's only one, and it goes Christina, right? The series now is going across. If I wanted to specify two values, I could specify an array in here and say I want 1000 and 1200. Okay, so now we have two values, so it's going to be more than a series, it's going to be a data frame. All right, and so now we have this data frame. We have customer ID 1000, and then her information, and then customer ID 1200 and her information, right? And so you can specify it like that, or you can specify it like with a colon. All right, so we can go from 1000 to 1200. So that's everything in between. Now notice this is not like slices. It can't be like slices because these are string values, not numeric values. So with slices, the last value is not included, kind of like with the range function, but with these they are. And it makes sense because if you want to get the values between, if these weren't numbers, if these were names, for example, if I wanted to get everything from, you know, Alabama to Argentina or something like that, I would want Argentina to be included. I wouldn't want the thing before Argentina. I might not even know what comes before Argentina. So since these are string based, the last value is inclusive, which is kind of contrary to normal Python when you're talking about using this colon operator and getting slices. So that's important. All right, so that's, and also when you're accessing items with .loc or in general, you are actually referencing items in a greater customer's data frame. So this is a subset. What gets returned here is a subset. And by default, Pandas has some protections where if you try to set a value on a subset, it won't let you, right? And that's, if you want to set the value, you have to set it on the original data frame. Okay, so that's important to be aware of as well. All right, so good enough. It's a good start. We've got customers.loc. So what else can we do with customers? We can look at the info. Shift enter. This is a data frame. You have 1190 non-null, and their object types. These are the non-null ones. City is the only one that's not missing data apparently because we have 1256 total, right? So just some information about it. You can also do customers.describe. So this tries to describe the information in sort of a general sense. It gives you counts of all of the items. It gives you how many are unique. So we have a lot of duplication. So right around 300 or so names are duplicated. Last names even more, right? Lot of duplicated zip codes, right? So, and then it also gives you the top. So how many of these are duplicated? Well, Ashley is the name that's duplicated the most, and the frequency is 5 times, right? Okay, so we can kind of play with that. Let's look at customer's first name dot head. Okay, so this is just the list of all of the first name fields, right, with our customer ID as the index. So this is a series, right? And then we can look at the length of this. It should match the length of our, oh, we did that above. You can use the len function here to just get the length of the items in the data frame. And now what we want to do is let's find those duplicates, right? So we saw the top value was Ashley, so let's see if we can locate that. So customers, and we want to find what? So what you can do inside of these square brackets is you can specify conditions, right? So we're searching for records where customers, their first name is equal to, and we can say Ashley. Now what's happening here? Okay, so the way Pandas works is now instead of previously when we were accessing something, we just specified a column name in here. Now this is different. Now we are specifying the rows that we want to return using this conditional statement. So customer's first name we know is a series, right? It's a series of the first names, and we're going to say where that equals Ashley. So it's very clever what Python has done here. It's overwritten the equality operator, and when you check to see if a series is equal to a string value, it actually checks to see if all of the values in the series are equal to this. And this is going to return a series of true or false. Okay, so let's just look at that by itself. So this is customer's first name, just a list of the first names, and this is where that series is equal to Ashley. So this is actually going to return a big series of trues or falses. And most of them are false because we know there's only 5 Ashleys. Okay? But when we pass this in, when we pass in a series to the square brackets of a data frame, customers, like that. So this is the series of trues and falses. We pass in a series of trues and falses that are the same length as our customer's data frame. Then that's basically telling our data frame to only select the values that are true. Anything that's false gets filtered out. Okay, so that's kind of how Pandas works in a nutshell. And so we've gone through our entire customer's data frame. This series, if the value is false, that's eliminated from the result. If the value was true, it shows up. Okay, so everything in Pandas operates this way. You have a series of data, and you apply actions to the series of data. So this is sort of a conditional operator. We want to select rows based on some criteria. All right, so we see there's 5 Ashleys there. All right, we can also see if we wanted to know, get some counts, some data about, like we know Ashley is the most frequent. What if we wanted to know the other frequencies of names, right? So we can say customers dot or first name. So again, first name is the column name. You don't have to use square brackets here. You can say first name. I don't recommend it though, because a lot of times your columns will have spaces, and then also if your column name conflicts with a built-in function, it won't be used, and you'll have to use the square brackets. So I always just use square brackets. That's kind of up to you though. All right, so we have customer's first name, and we want to say, what are the value counts? Okay, so remember, customer's first name is just a series. It's one column of our data frame. We want the value counts, and we want the top ones. So there's 5 Ashleys, 5 Leslies, 5 Sals, Fredericks, Beckys, etc. All right, so we could, if we wanted more, we could say the top 20. We'll get some more. Right, so those are the value counts. So it goes through and counts how many occurrences are there. So that's what value counts does. It's built into series. So you can always use that on any series. How many values are in A, right? So I can say customers first name is in A. Now remember, is in A just basically means null, right? So how many are is in A? This returns a series. Okay, so just like we did up here, this returns a series of trues and falses. So this is returning a series of trues and falses of the things that are in A. So we can pass this in to our customer's data frame, and it will give us the values that have in A values, and we can look at them, right? So we can say customers first name. So this is a series, and then we're changing that series to be a list of Boolean values, and it's going to be true where there's a value where the first name is not available. Right? So this is filtering. We've got 66 total rows. Okay, and here we see NaN. That's that value. This is what Panda does by default when you have an empty string or a null value, or the number can't be converted to something that's supposed to be a number, right? So we're selecting the is NA values. All right, so we've got enough information now. We can kind of solve that first problem. So normally you wouldn't have to do all of this in your data science, but we're kind of like exploring data and learning. We'll go ahead and keep all of this in our project. But for now, we want to label our solution. So I'm going to press escape, go to markdown mode, press enter. So markdown mode was with the letter M, and then pressed enter to enter the cell. We're going to add our horizontal rule, and we'll say solution 1. Okay, so solution 1, what do we need? We have the field name, that's going to be first name. So I'm going to set this up kind of generically because we're gonna do this for the first 4 problems. We want to know, how many missing fields there are. So we're going to say we want the length of this list, right? We know that's 66, but it's customers, the number of NA values where the first name is NA. So it's going to be customers, that's our data frame. We want to select the records from the first name field, customers first name, where they are not available. So this is going to give us that Boolean series of trues and falses. It's only going to be true where the first name field is not available, which is going to mean our customer's data frame is going to filter all the columns that it'll filter out all of the false values for the row, and if it's a true value on that series, then it'll show it. So the length of this should be 66, and we're going to divide that by the length of our customer's data frame. So that's the total number of entries, right? And then this is a percent, so we're going to multiply by 100 and save this in a variable p. All right, and now we just want to print it out nicely. So always label your solutions, and a big part of data science is, presenting the data. So you're doing all these complex calculations, but you need to present it in a readable format. So we want to present the percentage. So this is the value P. We want to present that. We want to have a percent symbol afterwards, and we want this to go to 2 floating point values. So this is a format string. Everything in the curly braces gets injected into the string. So we want to inject the value P, which is our percentage. We have a colon, and here are the formatters. We want to go to 2 decimal places, a floating point decimal. So this is going to round to 2 floating point decimal places. So that's the percent. Missing, and then we'll specify what field we're talking about. So this is field name, or just field. Fields. Okay, so we run this. 5.25% missing first name fields. And if we go back at our results that we found, the answers or the results either 5.25 missing first name results fields. Right? So now we can see we can pretty much duplicate these pretty easily. So like most of these, once you get one, the next one's really easy. All right, so the first one's always the hard one. So let's move on. Press escape, press M for markdown, press enter, and we've got problem 2. And what's our problem 2? We go up and we can copy and paste that real quick. All right, that's problem 2. Shift enter. If we have any work we need to do before we solve it, we do that. Here we know what we want to do, so we're just going to go escape, markdown, enter, and so we've got our solution ready. So this is solution 2. Press enter, and just basically copy and paste this, because the only difference here is we're searching for the last name field, right? Same calculation, so it's just last name. Shift enter. I need to put in field here. There we go. So now it's nice and generic. There we go, 3.18. If we go back to our file, our results that we saw, 3.18% missing last name fields. So the next 2 are going to be very easy. Same thing. Escape, markdown, enter, horizontal rule. Problem 3. Enter, enter, pound, pound. Let's find the problem. Number 3. Copy. Paste. That's the problem. We already know how to get to the solution. So escape, M, enter, solution 3. Shift enter. Copy and paste this. So you want to make sure you label things really well, because you will have long periods of code where, see how we've got all this work that we're doing in here, and then we need, for whoever's reading our document, we want to go ahead and say, okay, now here's the solution. So problem 3, solution 3, and it's not last name. We want to know what percentage of zip fields are left blank. 1.27. We can double check. 1.27. That looks good. All right, now once again, escape, press M for markdown, enter, horizontal rule. Problem 4. What's problem 4? Scroll up. Scroll down. All right, and then now we have escape, M, enter, solution 4, shift enter, and again copy and paste. The first 4 problems are essentially the same. They're just asking different fields. So we want to know the state fields. So again, we're grabbing the customers where the customer's state field is NA, is not available. So again, that's equivalent to is null. There is actually a function called is null, and they do exactly the same thing. But Pandas is moving towards NA for everything. So this is what you want to use. Is NA means is null, is not available. All right, Shift Enter, 2.15, double check, 2.15, that's good. And now this one's a little bit more tricky. We want the swapped state and zip fields. So this one we'll probably explore a little bit more. So we have a escape, markdown field, enter, horizontal rule, problem 5. What is problem 5? Scroll up. Copy. So you want to be organized. That's very important. So we've got a system. So let's play around with problem 5 here. What do we want to find? We want to find where the state and zip fields are switched. Well, how can we determine where the state and zip fields are switched? So let's look at customer data. And we want to find where customers, keep doing that, state field. We want to know where this is like a number, basically, right? Because the zip code is always 5 digits, right? So in Pandas, you can do some nice things where we saw you could change the type, .as type. And so by default, it's going to convert the integers to integer values, like the zip codes are going to be integer values. But we want to convert them to strings, so we can apply the string method is numeric. All right. So if I run Python, just here, if I have a string and I have apple, I can call .is numeric, and that's false. But if I have a string that just contains digits, it's true. So that's a nice way we can determine if that field is our zip code. We could also check the length of it, but that might be a bit too much. You know, you have to kind of know your data and kind of look at your data. So we want to say, you know, where is the state field? We're going to cast that as a type string. And here's the really nice part. If I want to use a string method on every single item of a series, I just type dot and then the type. And now I can access any string method, is numeric, for example. And this is going to apply to all of the elements of the series. So this is a series. We're casting the whole series as a string. Now we're going to access a string method and run this for every single value in the series and return a series that is the result of this. So this is going to be a Boolean value of trues and falses again. And the false ones are going to be filtered out, and only the true rows will remain. So this is a common theme in Pandas. This is how you select items from a data frame. Okay, so here, the state field. We get to look at all of these. So all of these they're cast as strings here, and we see that they are indeed zip codes. They're 5 characters. All right, so those are the ones that are swapped, and we also see the zip is over there. Now we don't know, it could be if some of these are missing or not. It could be we have a zip code that has been swapped with the state, but maybe the state was blank or vice versa. So we could do some more investigation and try to figure that out. But for now, what do we want to find out? This is this gives us the state columns that are strings. We might want to look and see separately the zip columns that are 2 characters. Right, so how can we do that? So we could say customers. We want to look in our customers data frame under zip, and we want to see where zip. And basically, we want to do something like this. We want to see if the zip code is in the list of states.keys. Right. So that's our list. That's our array of Up at the top, we add our helper. That's our states dictionary. And the keys is going to be the list of 2-letter codes. So we're going to see if the zip code is in states.keys. But the problem with this is this in keyword is going to check to see if this series is in there, right? So this isn't going to work. It's going to check to see if the series is in here. What we want is a series of trues and falses so that we can select from our customer's data frame. So there's a built-in .isIn method on all series, and that's exactly what it does. So it's going to check to see if all of the values, if it's in these. Okay, so this is the list. So 2248, 2248. We could check the length of these. So this is swap states. And then this is swapped zips. And we'll take the head of that. And then we can count these. We can say, you know, what's the length of swapped states and swapped zips. Oh, we need length of swap states, comma, length of swap zips. 17 and 17. So it's the same. So that's nice because we know it's the same. We don't have to check for both things. As I said, it could have been like one of them's missing and they were swapped, and so it could be a little complicated. So I'll show you how we could check for both things, but that gets a little bit verbose. So how could we check for both things if we wanted to? We could say the swapped values are customers, and we want to check for customers where state is as type string, and then we're going to access the string method, and we're going to say is numeric. So this is going to be all of the fields where the state is holding something that has numeric values as the string, right? But then if we want to do two comparisons, and both of them have to be correct, it's kind of clever what Pandas has done. It allows you, it's overwritten these operators, the ampersand operator. So we can't use and because that's already reserved. That's a reserved word in Python, and it's going to compare this as a Boolean statement and something else as a Boolean statement. So they overrode the ampersand, and then what this is going to do is basically create a series. So this is a series of trues and falses, and it's going to AND the following series of trues and falses. So both of those things have to be true in order for the final result to be true, and the final result is a series of true and falses. Right? And so both of these have to be true. So the other thing that we want to be true is basically just this customers zip. We do zip, and the dot is in. So this is going to apply into every single element in that series. We want to see if it's in. And instead of using states.keys, I think we can use our states series, right? And let's see if that should get it. Is in states series. States SRS is not defined. Didn't we define that up there? Oh, we have months SRS. So months. So this is the states data frame. Data frame. Oh, so this will be in the index. So the data frame values are the long values. So this won't return anything. States. Swapped. Head. Shift enter. So these are the long names. What is it? Dot index. There we go. So this is the index we use. The states are the index there. And so, so again, we showed this is the way we're used to doing it in plain Python. We want to use data frames and we want to use series in pandas. So instead of doing that, we have this data frame, and the value of the data frame, the states data frame, I'll scroll back up here. Right, this is our states data frame. The abbreviation part, this is the index, and so it's not technically a column. And then the only column is here in state. Right? But I can list out the index values as an array using .index. Okay, so these are some little tricks. And basically this gives us all of the swapped values. We have the length of swapped, 17. Okay, so that's kind of the long way, but since we know that these are both getting the same things, we can just use one or the other, because what we're going to try to do is when we clean the data, this is going to become a factor, because as I mentioned, when you select items from a larger data frame, these items are referencing the individual items in the larger data frame, but I can't just set the values on this object. It's going to give me an error message. I have to set them on the original data frame itself. And that's just to protect you from doing something silly. All right, so if I had to set a value based on this is a much larger query than just doing this. So we're just going to do one of these when we clean the data. But we're not actually to cleaning the data yet. We have to finish number 5. So let's get to the solution. How many swapped do we have? So let's escape, markdown, enter, solution 5. And we just want to print out format string. We have the percent is equal to, so we want print 0.2f percent swapped zip and state fields. All right, what's the percentage? The percentage is going to be the length of the swapped divided by the length of the total customer's data frame, and it's a percent, so we multiply by 100. 1.35% swapped zip and state fields, state and zip fields, same thing. All right, so we'll make it the same. All right, shift enter, run it. That's solution 5. Okay, so now we're ready for problem set 2. All right, press escape, markdown, enter, problem set 2. Escape, markdown, enter. Problem 6. Let's look at problem 6. So these are quite a bit different. What product generated the most revenue over the entire year? And what was the amount? Okay, so we scroll back down. And for these, I think it's important to kind of highlight the equation that you're going to be using. And here we've got it. I'll just get it from here. So this is the equation we're going to need. Now, of this problem set, this is the hardest problem. Problem number, this is actually, we're going to pair these together. This is problems 6 and 9. Right? Because one is the most revenue, so this is number 6, and least, this is number 9. So we're just going to generate a chart that has everything in the chart, and you can see both at the same time, and that's kind of the nicety of pandas. All right, so we're going to kind of pair these together. Now, before we go into problem set 2, we still have to clean our data. All right, so this is our next set of stuff that we have to do. But like I said, we have to clean the data. We found that there were issues, right? So after solution 5, let's go ahead and click on this cell. If I want to insert a cell before, I need to make sure I'm selecting the cell and not in the cell. Click on the cell, and I want to add something below, so I press the B key. If I wanted to add above, I'd press A, so add a cell below. And what we're going to do here is say markdown, and we're going to clean the data. So we always have to clean the data, make sure we're working with good data. And here, again, I want to add below. And I've got, let's clean the customer data, escape, markdown, enter, clean customers. Okay, so what do I have to clean with the customers? My view keeps changing on me, sorry about that. I need to swap those zip and state fields. That's the primary thing I have to clean there. And notice I have a field here. I'm about to run it, but I want a new field underneath. I can press Alt Enter instead of Shift Enter. Alt Enter will run it and add a new item underneath. So I want to clean customers. Basically, I want to swap those two fields that I found, right? So I mentioned that if you want to change a value on a data frame, you can't do it from, this is like a slice of a data frame. The swapped values is a small subset of the larger data frame. So Pandas won't let you do that. We have to do that from the larger data frame. So what we have to do is make those selections, customers, and this is why I was saying we would have to select all of this stuff if these were different values, because we want to make sure that they're swapped, that we get the right values. But since we know they're both 17, we can just take one or the other. And so this is the smallest one, and so we can specify that in here. So this is the number, or this is going to be the slice of items that the zip field is in our states data frame. So the zip field is containing the 2-letter state abbreviations. Okay, now we are referencing this from our original data frame, so we can set this equal to something. So this is a data frame, and we can select, we can say we want the state field to be equal to something. Right, so this is a data frame selecting individual rows, and then we're selecting a column. Whenever you're selecting rows and columns, instead of doing it back to back like that, you want to use .loc. All right, it's still square brackets, but now you are accessing the column or the rows first, comma, and then the columns state. Okay, so this is a safer operation when you're accessing rows and then columns. So you do them all in one operation instead of multiples, and it's safer in Pandas. So what do we want to set this value equal to? We have our swapped data up here, swapped. Now we have to be a little bit careful here because swapped is a subset of this. If we change this, swapped will change as well. So what I need to do is make a copy of that first. I'm going to say swapped equals swapped dot copy. So now this is no longer tied to our customers database or our customers data frame. So swapped I want to set it equal to swapped, and it's going to match up by the index, because the number of values here is the same number of values here, because we filtered out, right? So these are where state, zip and state are swapped. So I want the state field now to be equal to what we have in the zip field. And then over here, I want the zip field to be equal to what we have in the state field. All right, and then let's just look at what we have. This is going to show us all the ones where our zip field has the 2-letter state code, and it should be blank now because we swapped all those fields. Okay, so it's a series. It's an empty series now. Right? If we got rid of the loc and just got the whole data frame, it's a data frame, but there are no records. So that's a good thing. Now I want to show what happens. Yeah. No, I don't need to do that. If we didn't have this copy, though, once we set swapped, the state value to swapped to zip, then the swapped value of state would have changed as well, because swapped was a slice of the original customer's data frame. And that's really important. That can be very confusing. So make sure you're getting copies of data when it's appropriate. So we got a copy of that data to make sure that when we set the value of customers, it didn't change what we had here in this data frame, what we're setting it to. Okay, so we cleaned customers. That's not too bad. Let's see. If we want to, we're going to have an issue with our states in our customers' data because they have the .nan, or the NA values. So we do need to clean that up a little bit. So let's hit Alt Enter. We run that, and let's make sure I didn't accidentally double up something. So swapped should be, I might have swapped them back. No, it would show up if I swapped them back. Okay. Interesting. All right, so we want to get rid of the state fields, that NA value, because we're going to need to reference the blank value for state. We want that to be an empty string. So the last thing we do here is we want to say customers.loc, and it's where the state is NA, customers state. This is the state series. Dot is NA. And we want to select the state column. So again, we're using .loc. This is selecting rows. So we want to select the rows where the state field is NA. And then the column, we're selecting that individual column. So on all of those, we want to set this equal to empty string. So this is going to be the empty string now instead of NaN. And what we can do to check this is we can say customers . We want to check where the state is equal to the empty string. And here we have the state field. Previously, this would be NaN values, but now it's the empty string. And the reason we want to do that is because we have this dictionary. We want all of our data to be consistent, and we want to be able to apply all of the data to some other table if we want to. And so we have this empty string maps to empty string in our states dictionary, right? And so even in our states data frame, let's see, we have a dot shape. notice there's 51 values. So even in our data frame, we have one value of the empty string, an index of the empty string, and a value of the empty string. Okay, so I'll put that back to what it was. Okay, so that's why we need to clean that up a little bit, because we're going to be applying the state field, and we're going to be basically running it through that dictionary to get the longer version of the state name, so we want to make sure that there is an appropriate translation. All right, so that's cleaning up the customers. We can say customers.head here, make that a little bit shorter. So that's good. We set that equal to there. Now we need to clean up taxes, right? We did taxes last time, so Alt-Enter and Escape. M for Markdown, Enter, clean taxes, tax rates. Clean our tax rates up. So Alt-Enter, we want to add another field underneath here. So let's first get our tax rates CSV file, right? So that's going to be pandas pd.read_CSV. We're going to use our URL prefix plus then the name of our file. So this is just tax.csv. And then if we were to do this, we would get the normal kind of data frame where the index values are 0 and they increase. But we already know we want the index to be something from our data, right? If we explore our data here, we've got our data files in here, tax. I want this state field to be my index. Okay, so that's what I'm going to do. I'm going to change this, and we can do that right from the read CSV function. So I can say I want my index column to be state. So I'm specifying the label here, and so these will be my index values instead of having them just be numbered. All right, so that's going to read in that, and I can take a look at it. Tax rates head. Okay, and so here's what we have. We have the index values, we have the rates, and the rank. All right, so let's look at this. Alt-Enter gives me a new one underneath. So what do I want to do? First of all, I don't need that rank column. So whenever I'm doing data science in Pandas, especially, you tend to be using large data sets. So I like to remove columns that I'm not going to be using, so I'm not taking up memory. Right? So I'm going to say tax rates, and there's a drop function that I can call to drop a table. And I want to drop a column. I want to drop the column rank. What axis am I talking about? Is there something here called rank? So that would be axis 1 or axis 0 if I was talking about dropping a particular row by an index, but this is the index for my columns, so I want this to be axis 1. So axis 1 means I'm going to drop something along here. So going along this axis, it only makes sense to be dropping something, one of your columns. So I'm going to drop that, and yet again we have to do the in place equals true. If we don't do that, then this will just return a second table that has this removed, but the first table will still exist. Okay, so we want to modify our table that we have, and then take a look. All right, and so now we've just got our rate, so we still need to clean up our rate a little bit, so Alt-Enter. Oops, I already dropped it, so I can't really Alt-Enter. So if you get to this place, I accidentally coded this up in such a way where I can't rerun the cell, because once it's dropped, it's dropped. So you can go to kernel, restart, and run all, and it will run everything from the beginning. Okay, and we just have to be careful not to run that one again. So here we have these columns. What do we want to do here? We want to find where they're in A and set that equal to 0. And then the other thing we want to do is these are all going to be strings because they have a % symbol. So we want to strip off that % symbol, and then we want to convert that to a float, and then we also want to divide by 100 to give it an actual rate instead of a percentage. All right, so those are the things we want to do. So we say tax rates. We want to set values. So we're going to access rows and columns. What rows do we want to access? We want where tax rates, the rate column, we want to know where that is in A. Wherever that's in A, we want to set the rate column equal to 0.0. We're just going to assume the rate is 0 if there's no value given. All right, so that's one thing we want to do. And we can look at we can see the changes, tax rates down ahead. And I'm going to say Alt-Enter. Okay, so we've got the rate 0, 0 there. That's what we want, and this is a number. We want to convert all these from strings to numbers like this. All right, so to do that, it's a little bit more complicated. We want to, again, say tax rates dot loc. So we're grabbing a location. It's going to be a rows, comma, columns. So the rows we want to select are tax rates. We're going to look in the rate column, and we're going to cast this as type string. So we're going to cast all of these as strings. Even though this one's not a string, we're going to cast it as a string, right? Then we can call the string method, .str, and the string method that we want to call is strip. So we're going to strip the percent values, right? And then what we can do is there's another function called .apply, and .apply is kind of, you can do whatever you want with .apply. It goes through every single one of these values and applies some function. So whatever function I pass in here, it's going to apply it to every single one of the values in the data frame, right? So that's kind of the idea. What we want to apply here, we want to convert everything to a float, basically, but we want to use the NumPy types, so the NumPy data types. So we don't probably want to pass in float. We want to just say pandas dot to numeric. And that should handle it. So this is effectively like we're converting this to a float. Whatever's in there, we're converting it to a float. And then we want to .apply one more thing. What do we want to apply? Well, we have to multiply by 1,000. So I could define a function to multiply by 1,000 or just use a lambda. A lambda is a quick little function. So this is like define some function, and here's the parameter. And whatever the result of this expression after the colon is, that's what gets returned. So I'm just going to say x times 100, right? And that's really all there is to it. Actually, this is, so they are percentages. We need to divide by 100 to get them as rates. So x divided by 100. All right. I'm sorry, this is what we're setting it equal to. So our .loc, so we're getting the tax rate column, that's a series. We're casting all of those values as strings, and we're calling string.strip, and then we're essentially casting all of those values as numeric values, and then we're dividing by 100. So that's our end up value, the thing we want to end up with. Where are we doing this? We are doing it for all of the rows and the column rate. Okay, so we're changing tax rates data frame. Where are we changing it? All of the rows at the location, the column location rate. What are we changing it to? Tax rates rate. So we're going to start with this column, cast it to a string, use the string function. Which string function? Strip. We're going to strip off the percentage. Then we're going to apply this function, which converts it to a float, and then we're going to apply this little function, which divides by 11. Okay, so this is kind of standard. It's a little bit hard to read in Pandas. This is getting a little bit long, but this is the type of thing you'll see in Pandas, right? So tax rates.loc, and then we want to check to see if it worked. And so now we have rates here instead of percentage values. Okay, so we've cleaned our tax rate data, and now we are ready for problem set 2. Okay, so we needed that tax rate data in order to do this. So now we can get going. This is problem 6 and 9. So we can use sort of a naive approach. Let's escape Markdown. We'll label this as kind of a naive approach. So now that we know something about .apply, we might want to just use that kind of everywhere. First, let's get our products. So we can say pandas pd.read CSV. We have our URL prefix plus, and this is just products.csv. We want the index column. It has a unique index of product ID, so we're going to call the index column product ID. And then say products.head. Products. There we go. So this is our products list. This is just the first few elements. There's not a whole lot in it, but we have a price and a cost in the products list. All right, and what else are we going to need? We're going to need our sales data. We're going to say our sales data, we're going to use an array of data frames, right? So this is a list comprehension pd.read CSV. We're going to have a format string here, URL prefix, sales hyphen, and then we're going to have some I value here formatted. We're going to pad it with a 0, right? .csv for I in range, and this is going to go from 1 to 13, right? Because there are 13 values. The sales data is going to go sales hyphen 01, 02, 03. So we want to start at 1 and we want to end at 12. So in range, we don't ever get to the last value. So what this is doing is we're going to inject 1 here, but we want it to pad with the 0. We want it to pad to the right. So our number 1 is going to be padded to the right. And it's going to be a 2-character window, right, for I in range 1 through 13. So this is going to give us an array of these, and we can kind of test this by saying sales 1, this should be February, .head, and take a look at the items there. So notice the little star was there, and that means it was calculating. We just downloaded a whole bunch of data, so it took a little while. So you've got a spike up here. This is my network activity, and so I downloaded 12 big data files, and it took a second to parse all of that. But here, this is February's sales data, right? We know it's February. We can look at the date, 2020-02, right? So some sales data, taking a look at that. All right. Now that we have that, what else do we need? Let's just try to get 1 month. Okay, so we know from our example before the results, we know October had the most revenue. All right, so October is the 10th month, right? So let's play around with that, and we're going to say our month is sales 9. That's the 10th element in the list. So our month there is October. Now again, this is the naive method. We're going to use .apply and get to the result and play with that. So we're going to say what we want to do here is first we'll make a copy so we don't mess up our original sales data, because we're just kind of playing around here. But we want to go through each one of these values. We want to go through all of the rows and the column price. And we want to set this equal to something. So our monthly data doesn't have a price column. So what I'm doing here is I'm saying in every single row, I want you to add a price column. If it exists, it would modify it. But if it doesn't, it's going to add a price column. Where am I getting that price column from? I can get my month product ID. And I can apply a lambda function here. And that lambda function is going to get that product ID and then get the location of that item from our products list at the price column. All right, so this is going to say lambda product ID. We're going to get that products data frame, and we're going to get the location at what row, product ID, and what column do we want to access, price. All right, and so we can look at this and we can say mo dot head. And what we've done is we've gone through and used apply, and we've added this price column. So for every element in here, this is a bunch of sales data. Every single sale, you sold the widgets, gadgets, all, and there's duplicates, right? But each one, we're going through and we're adding a price. And if we get everything in one big table, then we can make the calculations really easy. Now, it does take more memory to do this, but ideally in Pandas, that's kind of what you want to do, is get things into a big table that you want, removing data as you go that you don't need to save memory, and then make your calculation. Now, the apply method is rather slow, so we don't want to do this very often. This is why this is kind of the naive method. There's a better way to do this. But we'll go ahead and finish here. We want the price as well, or the cost. So we can do the same thing, but we want the cost. We want product ID.apply and get the cost. Right, now we've got price and cost of these items. Right, and then we would also want to get the tax. So that's going to be a little bit more challenging. So you could say mo, the month we're talking about. We want to get the location. For all of the columns, we want to add a field called tax. And we want to say we'll get the month's customer ID. So we have to, if we're looking at the data, we have the customer, here's the sales data for October. We want to get the customer ID, and we want to place that in the customers, or basically grab the customer associated with that. So 1984. So that's, we want to grab this customer. We want to get the state, and we want to translate that state to the long version of that state, and we want to use that in tax. And we've already converted this to a rate in our table, so we would want to get the rate field of our data frame. So that, it's kind of a lot that we're doing there, and we're kind of doing this in a naive way, kind of the way we solved the problem here with sales 10, problem number 10 in plain Python. We're kind of solving it the same way. We go through, I guess this is number 6. We go through, we get the product, we get the customer, get the tax rate, and then translate it through the state, right? So we're doing the same thing, but we're doing it in sort of a Pandas syntax, right? So we get the customer, and then I'm going to use this / syntax so I can go to a new line. Otherwise, this would be too long. And we want to apply a function. What's our function here? We got customer IDs. So remember, this is grabbing the series of customer IDs, and we're going to apply to each one of those this function. So each one of those is a customer ID. We're applying, we want to access something from the customer's data frame. We want to get something, so we're going to use .loc, and we want to get the customer ID row. So whatever customer ID we're talking about, we want to access that row. And what specifically from that row do we want? We want the state. Right? That's going to give us the, in our case for that first one, it's going to give us GA, that Georgia code. Right? So this is going to give us, for every single one of our customer IDs, this is going to give us a series of that customer's state 2-character code. Right? And then we're going to apply another function, lambda, and this is our abbreviation, so it's the 2-character code, right? And we want to use our states dictionary and pass in the abbreviation, and that should give us the long state name, right? And then we'll apply another function. So this is going to be a series. This was a series of customer IDs. We can converted that to a series of the states associated with each one of those customers. Then we can converted that, and that's the abbreviation. Then we converted the abbreviations to the long state name, and that's a series. So it's a series of all, each one of these lines. So each one of these series is the same length as the original month data, right? So month is the sales data. So however many sales there are. So this is a series just as long. All right, and then we want to apply lambda, and we've got this state value that is, we really want the tax rate from our tax rates data frame. So we want to get a location from there. We want the state, so the index, the tax rates are indexed by state, so that's the row we want. And what's the column we want? We want the actual rate associated with it. So you can see how you can do things in pandas like this using .apply. And .apply is slow. That's not ideal, but when we get done, we can take a look at what we have. We got a little error here, key error 1984. So I think we needed to fix up our customers. Let's see, our customers, customer IDs should be strings. Right, so it's saying there's a key error of 1984. And so let's see, it's pointing at this one, customer ID. So this is, so the way you kind of debug this, notice there's no string value here. It's a floating point decimal. And this is the line is messing up on. Right? Specifically right here. So we have this customer ID of 1984, and we're trying to access something in the customer's database, but that customer database, we changed that to a string. Remember, we changed all the customer IDs to strings, but we didn't change the customer IDs in all the sales data to strings. Right? So we might want to go through all of our sales data and see if we can convert the customer IDs to strings, or alternatively what we could do is just in this lambda convert it to a string. Yeah, so let's do that. Let's go up a little bit to all of our sales data. So here's where we read in the sales data, and right here in the read CSV value, what we can do is we can add a D type, and we can specify for the columns in our CSV file what we want the data type to be. So for customer ID, we're going to say we want the data type to be a string. And then we're going to read in all these again. We'll see the network traffic go up here. Shift enter. There's our network traffic. Okay, so that executed. So these should all be strings now. Now we can run that. Key error, empty string. So one of our strings is empty. So this is, let me look for our code here. So we get an empty string here. And so tax rates. So one thing we didn't do on our tax rates is, what if the tax rate for the state, what if we have a state that's the empty string? So when we cleaned our tax rate data, we didn't add an empty state field. So this is getting a state as an empty string because that customer just didn't have that value. And so we're putting it into our tax rates data frame, which doesn't have an entry for an empty string. Right? So we need to do that. We need to add that. So if we go up to our clean data and tax rates, click on this. I'm going to add below by pressing the B. All right? Add below. We need to clean this up. We want to add tax rates. .loc. We're going to add a location, and we're going to set that equal to the array of data. So there's only one thing here. So I'm basically saying at location here, I'm setting this equal. I'm adding a brand new record, and if there were a whole lot of records here, it would be an array of data. But here there's only one record, so it's just an array of one value. So I want, if there's no state specified, I want that to be 0.0, right? And this should modify it, and we can double check that by saying tax rates. Let's look where the tax rates rate is equal to 0.0. Okay, so all of these states have no tax, and then now we have the empty string 0.0. Okay, so hopefully, let's see if we're better off here. Let's run this one more time. Shift enter. There we go. All right, so that's how you debug things, though. It's really important that you know how to do that. Look at the data type. If it's a key error, see if it's a string or not, and then look to the part of your code that's actually causing the error, and then kind of think through why that might be the case. All right, so what we've done here is we've gone through, and now we have a table with all the information we want, and so I could calculate the tax, or let's see, what are we calculating? Most revenue and least revenue. Okay, so the revenue equation we said was this. So this is price times quantity times 1. So that's what you pay for the item, plus the state tax rate times the price times the quantity. So 1 plus the state tax rate times price times quantity. That's revenue. All right, so now that we have all of this information in one table, now this gets really, really easy. All right, so to do this, we have our month, and we basically just want to calculate some revenue. So we'll say the sum is, you've got our monthly data, and we want to calculate the quantity times, so we do have a quantity field in each one of these. So this is the series of data times another series of data. It's basically going to one-to-one multiply these things together. It's going to multiply 7 times 9.9, right? Whatever you specify, it's going to multiply them as series. So this is going to be our month's data times price, and then times 1 plus our month's data tax. So this is going to give us basically a column, we could call this column revenue here, but really we just want the sum of all those things. So we can sum this all up using the sum function like that and print it out. So we just, this is going to be dollars, right? So we want a dollar sign. We want to print out our sum. We want to format it. We want commas every 3 place values, and then we want to round to 2 floating point decimals. Right, so we can do that. So 42,557 and 66 cents. So let's look at our results. October. Yep. Okay, so again, this was the naive way of doing it. Also, this whole thing here is a series, and so it has a built-in sum function. You can do this as well. And this is probably more efficient if I had to guess. Maybe not though. All right, so you're summing all these things together, and this is our result. So that's the naive way. Let's do a better way. We'll do more of the pandas kind of way. So we'll say the solution here to 6 and 9. We're ready to do that. So escape, markdown, enter, solutions for 6 and 9. All right. So we basically want to define a function, get monthly revenue. And we want to pass in some monthly revenue each time. And we're going to get the result of this and make a data frame out of it. All right, so we're going to get a data frame, and the first thing we're going to do is copy our monthly data so we don't overwrite anything. Right? We need to use the sales data in other problems. So we're going to make a copy of it, and let's drop the data fields that we don't need. So this is, remember, this is our invoice, customer ID, the date, all this stuff. So what don't we need? We can say data frame dot drop. What are the fields that we want to drop? We're going to have an array of columns that we want to drop. We want to drop the date. We want to drop the invoice number. We don't need that. This is just to save data because we're talking about big data and there's a bunch of fields here. What axis are we talking about? We're talking about axis number 1. So this is axis 1, and then this would be axis 0. We want to drop from axis 1, so we're dropping invoice number and the date field, and we want to do this in place. All right, so we can drop those items. We want to, now what we want to do is talk about merging tables. Okay, so if we merged a table, it basically matches a value. It's basically everything we were doing here on apply, right? When we're using this apply, we're saying, okay, product ID, we've got this value, and we want to match it against something else in this table. So we're matching the product ID here, and we're grabbing the product ID there, and then adding fields, okay? So we can merge the products table and basically just add the price and cost columns for everything that matches product ID. So whenever we see gadget, it's going to automatically include the price and cost from the second table that we're merging. All right, and there's a few different types of merges. We're going to do an outer merge, which means if there's blank values or values don't match, we still include them. All right, so okay, so we have a data frame. We're going to say it equals pd.merge. So we're going to be merging these data frames together. So we start with our data frame here. This is our sales data, but we've removed these 2 fields that we don't need. And then the data frame we want to merge is the products. Oops. Right, so we've got this product ID field that we want to merge with, right? So then there are parameters to merge. You say left on. So what is the column on this data frame that we're merging on. So again, with the merge, you're trying to match up a value. So on the left data frame, we want to merge on the product ID column, right? So left on product ID. And then on the right column, or the right data frame, what are we merging on? Well, in the right data frame, we want to merge on product ID as well, but we've made that the index of that data frame. So here, instead, there's no column to merge on. So we have to say right index equals true. Where if we were merging on a column, we would say right on and then specify the column. But since it's the index, we say right index. And so now you have to specify what you're merging on the left. So that's the column product ID. And what are you merging on the right? You're merging on the index value. And then how are we merging? This is an outer join. Okay. This is going to merge these and basically give us something like this. So price and cost are going to be added to our data frame. All right, so we can test this so far. Let's call get monthly data. Revenue. And we'll pass in one of our sales months. We'll pass in October again. And this should give us a data frame. And let's just look at it. Data frame dot head. So all we've done, we made a copy, we dropped a couple tables, and then we did a merge. So we merged that data frame with our products. I need to return it. Okay, so here, customer ID, product ID, quantity, and now we have our price and cost. Now it's duplicated whenever the product ID is there. So we are duplicating data. This is a little bit of a waste, but it makes the calculation much easier to perform. And so now we don't really need this product ID anymore. We needed the product ID to look up the price and the cost for each, so we can delete that column to save some memory. So we can say data frame dot drop. We want to drop the column product ID. What axis? That's axis 1. Remember, axis 1 is this way, axis 0 is this way. And in place equals true. Can't forget that. So that's going to drop that column. Run it again. Axis, not axes. Okay, so that got rid of our product ID column. We don't need that anymore. What we do want to do is get the tax, right? So to get the tax, we're going to need the customer ID, and we're going to merge that. We're going to merge this table with the customer's data frame, and we're going to add in the customer's data frame. There's a state, and that's going to be the two-state abbreviation, right? So we're going to do another merge. So pandas dot merge. What are we merging? Data frame df and our customers table. What are we merging on? On the left, we're merging on customer ID. So in one of these fields, wherever we have a customer ID, what we want to do is look on the customers database and grab all of the customers data frame and grab all of the values on that row. All right, so on the left, we're merging on customer ID. On the right, it's just the index again. So this is going to be right index because we have in the customers database, the customer ID is the index. So right index equals true. And how are we merging? We're merging outer again. And outer just ensures that we're not eliminating any values if there aren't any matches. All right, so that's going to be our new data frame, df. And so if we run this, left on, not on left. Okay, so now we see we got our price and cost from the product. Now we got our customer ID, and we've got street address, city, state, and zip. And this is all just based on this customer ID. So it's 1984. So it just goes ahead and adds the customer information to this whole list, right? And so what we get too much information here. We don't really want all this other stuff. We just want the state, right? So what we can do here is, instead of merging on the entire customer's database, data frame, I keep saying database, we want to merge on the state, right? So this is just going to be merging this. This is going to give us a series, but it's going to have the same index numbers, right? So it's still going to merge on the right index. And so now we have what we had before, and we save some space. So we're not merging every single property or every single column of the customer. We're just merging the state column of our customer's data frame. All right? But this isn't entirely what we want either. We are done with the customer ID though. We've got our state, so we can drop that. Now keep in mind, this is the hardest one. Then it gets real fast after this. So we want to get rid of the customer ID. So we say dataframe.drop. We're dropping the customer ID column. And we want to do that on axis 1. Axis 1 is this way. Axis 0 is this way. In place equals true. Set that equal to df. Okay, so we dropped the customer ID, which we don't need anymore. We want to convert this state to a long state name, right? So if I am converting that, I need to merge my states data frame, right? So we had the states underscore df data frame. So let's merge with what we have here. We're going to do another pandas.merge. So this merge is very, very powerful. We're merging our data frame we have, and we're going to merge that with our states data frame. Remember, our states data frame has an index of the abbreviations, and then the column is just the state name. All right, so we're going to left on. So what are we merging on the left? We're going to merge on the state column, and then right index is true. How should be outer. I don't think it matters though. Okay, so that's going to be our new data frame after merging. Data frame equals merge. Okay, so we've got state X and state Y. All right, and that's because we already had a state field and there was another state field. So this is from the original value in our data frame, that's state, it's the 2-letter code, and then the new 2-letter code. Right, so we can just kind of rename it. It's not a big deal. So let's just say df.rename columns, and we'll say state X. We're going to call this abbreviation state Y. We're going to call that state. Okay, so this is how you rename things. Rename the columns anyway. In place. Okay, so we rename that. We actually don't need this abbreviation anymore, so we can just df.drop. Oops. Abbreviation. Axis equals 1. In place equals true. Now that we've got the state, we can use that to look up the tax. So we've got another merge. Pandas.merge. What are we merging? This is going to give us a data frame. So we're merging our current data frame with the tax data, the tax rates. So remember the tax rates, the index values are the abbreviations, right? So in this case, the left on column that we're merging is the state, and then right index equals true. Let's see, is that right? Right index is true. And this should be outer again too. How are we merging? But I don't think it matters. Let's see, what do we got? State is not unique. Left on. Column label state is not unique at here. Let's merge. All right, let's take a look at what we have first. State. And then the right index. So the tax rate, we want to actually grab the tax rates column. I don't think that should matter. Is this an outer merge thing? Let's see here. States data frame. Oh, left on. So our states data frame, did we set the index for that or not? So we've got states, and so it is abbreviation. Okay, so on the right index, we do have the state. Okay, so we are getting the right thing there. All right, key error rates. That doesn't sound right. Let's take a look here and see what tax rates is. So you run into these little problems periodically. Let's just take a look and see what we're dealing with. So tax rates. Oh, it's just rate. Okay, so not rates. All right, and then what the other issue is, label state is not unique. So that's back to where we were. So left on, so our data frame left label state. So we called state X, we called it abbreviation, and then state Y, we called it state. We modified this in place for our data frame. Then we dropped the abbreviation, right? Let's let's just call it state 2 and see. Well, that's interesting. So, yeah, that's very odd. I'm not sure what happened there. So state, there was a reference to state. Both of these had state, and I changed the name back to state. I think that might have caused the problem. Let's see if we can, instead of dropping abbreviation, let's move this line up, and we're going to drop state X. And then we'll rename state Y to state. We don't need to drop abbreviation anymore. Let's see if this works. No, it doesn't like that. So column label state is not unique, even though I deleted the column. Well, that's a new one on me. I'll have to look into that and see why that's the case. So we'll call this state 2. State 2. I mean, we might as well just keep it as state Y if we have to rename it something. So we'll call this state underscore Y. All right, so that works. We got the rate. That's what we want. And so we no longer need the state because we only need the state to get the rate. Oh, here's the other state. Well, there it is. Now let's see what happened here. Let's get rid of the merge. Oh, we've got the original state. Oh, because there was an original state and the state Y. That's what happened. All right, so we merged our data frame. This is, let's take a look at our data frame again real quick. This is interesting to me. Sorry, this is a little side note. Okay, so we merged our states data frame on state, right? Index is true, right? So we run that. So now we have state, there it is. So we have state, state X, and state Y. Okay, so this merged and gave us two values of our data frame because we matched the index and the column. So what I want to match on the data frame is the state. No, that still does it. Left on state, right? Index true. It's an outer merge thing. So this is giving us two values, state X and state Y. It's because state is in both. So state is in this frame. So I need to rename this to abbreviation first because I want a state value, but the resulting state value is also called state. So it doesn't know what to do. It's got state X and state Y. So I need to change this to abbreviation before I do this merge. Okay, so df.rename columns. I'm going to rename state to abbreviation. In place equals true. All right, so I've renamed the column state. So now I'm going to merge on the left for abbreviation. And on the right, that's the index. There it is. So that got rid of the confusion because I already had a value of state. And so when you're merging, it didn't know which one to add. And so it had state X, which was the state field from the left data frame. And then state Y is the state field from the right data frame. So I changed the name and then all as well because we didn't have the two columns didn't have the same name. All right, so left on abbreviation, right on index. That's good. So now we can drop, instead of statex, we can drop abbreviation. And then run that, so that gets rid of abbreviation, and now we can go back to our tax rate. We want to merge tax rate rates on state, and then right index is true. So we should get a new field here called rate. Let's rename that df.rename columns equals rate, and I'm going to just call this tax in place equals true. So the more of these little functions that you write, the faster you get at them. And it's really good experience to just type this out. I know it's a little bit tedious, but the best way to get good at this stuff is just to do it. We run that, so now we've got tax. We don't need tax anymore, or the state anymore, because all we really need is quantity, price, cost, and tax. And so we can df.drop. What do we want to drop? State. And we want the axis is 1. In place equals true. Okay, so this is our data frame. We could also do a reset index. When you merge, the indices get a little screwy sometimes. In place equals true. So yeah, this is a aggregation from the merge. Let's see if we do reset. Yeah, because it's in place. Okay, it's not super important. We can reset the index and then drop df.drop index axis 1 in place. There we go. So now, this was the hard part. All the other ones are going to be way less work than this, and all we have to do is calculate quantity times price times cost. So let's do that real quick. We don't even need cost for this one, but we'll keep it in because we'll need it for one of the next ones. So we have this data frame, and what we want to do is we want to get the revenue is going to equal so we need to kind of comment this out. So we're getting the monthly revenue is what we really want to get. So we don't want to return the data frame. What we want to return is we want to get the sum of multiplying these series together. So multiplying price times the data frame quantity times 1 plus the data frame tax, right? And then if we get the sum of all that. So this would just be one series. It would be a series of all the individual orders, but there would be the revenue for each individual order, and then we're calling sum, which means we're just going to sum across that entire revenue field, revenue column. We didn't actually create the column, but this would be a series representing the revenue. We could add it as a column if we wanted. So now we can say the revenue is equal to get monthly revenue, sales 9, and then we just call it S again, and use that same print function from above. Tax rates. Let's make this dot head, make it smaller. Yeah, so this. So we get a format string, we get S, which is our revenue. We print it out. We want to include a comma and round to 2 floating point decimals. All right. So that's the value, but what we want to do is get this for all of the months. Right? So if we're getting this for all of the months, we want to do this in kind of a loop, right? So, and really we don't want a loop. We want a data frame of this, right? We're using pandas. Let's go ahead and make a data frame of this. So we'll say something like monthly revenues, and we're gonna create a data frame, pd.dataframe. Okay, and the data for this data frame is we're gonna have a list comprehension here, and we're gonna call our get monthly revenue function for each one of the months. So we've got some month of data, and so we'll say we'll do this for month in sales data, right? And then the column names we want to be called revenue, right? And the index for this table, instead of just using the index value 0, right? That's not going to make much sense because the first value is going to be January, right? We'll just set the index equal to our months array, which we already set up. All right, and we'll save this for later. So monthly revenues, let's look at so we've got this nice table. And now we want to add a section for readable revenue. All right, so monthly revenues, revenue readable, revenue. And all we really have to do there is just do a little apply function, right? So for each one of the revenue values, we're going to say dot apply lambda x. So x is going to be the revenue. And then we want to return basically a string that's readable. So we have a format string. It's basically this, right? So we have a $. We have our value x. We want to format it with commas and to 2 floating point decimals. All right, and revenues. So there's the readable. And then if we sort by the revenue column, then we'll get at the bottom, or at the top of the list will be the lowest value, and at the bottom will be the highest value. So what we can do is say dot sort values. What column do we want to sort on? We want to sort on revenue. And then in place. Revenue readable. So here, February 39, 391, 658, 95 is the lowest one. So February had the least, 391, 658, 95. That's correct. And then here, 432, 557, 66. And that's October. October, 432, 557, 66. All right. So the rest of them are much easier. Hopefully you have learned a lot from this so far. So let's knock out the last 3, and then we'll end this video and do the last section on a separate video. All right, so here, Markdown, enter. So now we're on problems This is 7 and 10. Right, solution 6 and 9, so this is 7 and 10. What are the problems? Let's scroll up to the top and find them. And these will be super quick because we did the hardest one first, and now we can knock out these. So that's that. Largest gross profit, and what was the value? What's our gross profit function? We got it up here. And we can skip straight to the solution because we already did all the hard work and we know what we're doing now. So this is solutions for 7 and 10. All right, so it's the same idea. We're gonna have this function. We're gonna go through and get the gross profits, right? And then print it out in a nice table. We're gonna have the value and then a readable value as well, and then we're gonna sort it again. So pretty much exactly the same thing. This is gross profit though. So we'll go through and change some things. We've got get monthly gross profit. All right, I can get rid of that comment and this comment. And so monthly gross profits. And we're gonna call monthly gross profit in here instead of monthly revenue. For month in sales, this is gonna be called gross profit. Index is months, same thing. This is gonna be called gross profit readable. Is monthly gross profits, monthly gross profits, monthly gross profits, monthly gross profits, gross profit. This is going through and fixing all of the revenues to gross profits essentially. Looks pretty good. Okay, so now what does this function do? So gross profit, what do we need for that? We just need price, cost, and quantity. So the individual monthly sales data has the quantity. So all we need to do is get the price and cost. We do that by merging the customer data, right? So we can go ahead and drop this. That's still good. We want to merge the product ID because the product ID is what is going to give us the price and the cost. I said customer data, but that's wrong. It's product data, right? So we want to merge left on the product. We get the right index, and then we can drop the product ID, and then all the rest of this stuff. This is getting customer stuff. We don't need that. We don't need the customer ID. We don't need the sales tax. We don't need any of this stuff, right? And you know, right away we can also drop the customer ID because we don't care about the customer ID because we only use the customer ID to get the tax. All right, and then what is our final calculation? Our final calculation is price minus cost times the quantity. All right. So we get price and cost from merging our data frame with products, and so we should still have quantity from our original monthly sales data. Right, and then we sum that up. We create a new data frame, call it gross profit, and then we create gross profit readable, and place true. Okay. And just like that, this one's solved. Okay, you do the hard part. Let's make sure this is correct. We sort by gross profit. So February, we have a calculation issue. Price minus cost. So yeah, I did price times cost. Price minus cost. There we go. Oops. Okay. That's a little bit better. Okay, so February 193, 381, 52. February 391. Let's see where we're at. The second one. 193, 381, 52. That's correct. And then October 213, 642, 37. And then October 213, 642, 37. All right, that one's done. And then the last one, we can knock that out real quick as well. So here, escape, markdown, problem, let's see, 8 and 11. And what are they? Scroll to the top. And this is net profit. So let's go ahead and copy that equation. And we can skip right to the solutions. So markdown, enter. Solutions 8 and 11. All right, and basically copy everything over here because we are going to use gross profit in our calculation, right? Because net profit, gross profit is included. But one thing we have to do, we'll keep that gross profit function for now. Let's comment all that. But we need to get our expenses data frame because the expenses, we basically have to subtract those expenses from whatever our gross profit is, and that's the only difference in net profit. So we have to get that from our CSV file. So let's say expenses equals pandas.read CSV. This is going to be URL prefix, and this is expenses.csv. And so our expenses file, let's see, what does it have as the index here? Let's see. Well, actually, we don't need any of this. We do need the expenses file, but we just need to copy this data frame. We can use this whole data frame and subtract the values from that, right? So we don't even need this function. So we can say, well, let's just look at expenses first. Plus. Okay, and so the month, we want the index value. So the index, the column index to be, how do we want to say that? All right, so the month here, this month is going to be, we want that to say like January instead. All right, so we can say expenses month equals expenses month dot apply. And so for each one of these, we're gonna, instead of a 1 value, we're going to give it the value in our array. So we're gonna say dot apply lambda, there's some x value here, so the x value is gonna be 1 the first time through the loop, and we want to return months we want to return the item in our array. So it's not x, it's x minus 1, because the first index item is 0, right? So month 1, 1 minus 1 is 0. That's going to be the first element in our month's array. All right, so now we can say expenses index O. There we go. So that's January. And so now we want to make that the index. So set index to month in place equals true. And then expenses. All right, so now we've got our expenses set up. That's good. So I guess that's kind of a little, this work should probably go in before the solutions. So we'll go up here, we'll press A, add a cell above, press enter. Okay, so now we have our expenses. And now here's our solution. So our solution, we want our monthly net profits. And this is going to equal, basically, we'll start out with a copy of our monthly gross profits. Right, that's what we called it. Yeah, monthly gross profits. And so we start with a copy of this. And then we're going to add a column, monthly net profits. We're going to call this net profit. And this is going to be basically taking the gross profit column, and then we want to just subtract the expenses, right? So net profit or gross profit already has the months as the index value, right? Our expenses also have the month as the index value. So we can just straight up subtract these two columns because the index values match, right? So we can say expenses data frame, the column expenses. That gives us net profit. Net profit. And then we want readable net profit. So that's going to be something like we did up here. I didn't change anything there. It was a little glitch. I undid it. Let's see. We went to, I'm just getting lazy and copy and pasting now. So gross profits is net. This is going to be called net profit readable. Net profit. We want to take the net profit field and apply this readability function. All right, so we got it readable, and we can drop the other two. We could drop them before we do this. So monthly net profits dot drop. We want to drop two columns, so we put them in an array. Gross profit, gross profit readable. We want to drop those axis 1 in place equals true. There you go, net profits. So that's the solution. We need to sort. So we didn't sort. So we can say dot sort values. We want to sort by net profit. In place equals true. Oops. Place equals true. There we go. So now the lowest is February 192.668.65. So the lowest is 192.668.65, and the highest is 212.986.06 in October. October 212.986.06. All right, and so we'll get to these on the next video. Thanks for watching.